Hey everybody, and welcome to another video from the Electronic Armory. Today we're going to talk about architecting your software stack for a mobile, web, and server application. So who is this video for? Well, anyone who could follow along, because I will be walking us step by step through the application creation process. But really this is for anyone who wants to build an entire web application with some mobile applications attached to it. This is going to be part of a larger series on how to build a robust, secure, and scalable web application with web and mobile clients. So if you've ever wanted to create a web app with some kind of server backend or a website, web application with some mobile apps that accompany it, this video series is for you. This is going to be the ultimate tutorial on how to build these things. As I said, there are going to be various videos in this series. So what are we actually going to be building? We're going to be building a fully functional web server with microservices. So if this terminology is not familiar to you, we'll definitely be explaining this as we go through it. We're also going to be building an accompanying Android and iOS application, which we'll go through each, and then we're going to tie it all together. We're going to use the software for the Electronic Armory website for course-based learning. This is something that I want to create for you guys that is software that is going to allow you to run through different tutorials that I have. And so I'm going to build this software right in front of you, but I also thought that I'd do the videos for them so you can see how it's actually built. So some considerations that I took into an account when I thought about what I wanted to build. So I thought about using out-of-the-box solutions such as Drupal and with a Pinyo or WordPress or something like that. But while I've built many applications and websites with these, I never felt that I had full control over the software, and I was often at the mercy of the developer. So if I had a bug, it was really hard for us to either wait or have to go patch that, and the code is very unfamiliar to us. So it's really undesirable at this point for this kind of solution that we want to present to you guys. But I will say that they are really fast to implement. It's out of the box, very simple to get a Drupal or WordPress site running. My mentality is share what you know. And so I wanted to build a website and an application where people can go and participate in a university level class just like the one I teach. I want to teach you all about how to put together monster-sized applications, but that's hard to do in 20 or 30-minute videos. So I wanted to share everything that I know about building large and scalable applications and put that in a course and share that with you. And you'll be using the software that we're building in order to go ahead and learn how to build that. And so I thought that was kind of interesting, and we'll see how it goes, but let me know if you like the idea and we'll continue going with this series. There are many ways to do the same thing. This is not the only way, the way I'm going to show you, but it is one of the best ways. It is using common best practices in the industry. I've worked on very large scale applications for companies in San Francisco, New York, including HP, Microsoft, Verizon Wireless, T-Mobile, Hasbro, and Facebook. So I worked on a lot of different things through a lot of different industries, and so I want to again share that expertise with you on how to build some of these things that you guys may be interested in building yourselves. This app won't be on the scale of some of those that I've talked about, but we can scale up to those and learn a lot about how software is built by these largest companies in the world by doing so. So make sure you subscribe to get all the videos that are going to be later in this series as I build this out. And let's get started. We're going to start off with a proper foundation, because if you don't, you'll be sorry. You'll be stuck with loads of technical debt, and you may never fully get out from under that. I've seen companies start and when they're starting to develop their applications, they just start throwing stuff together. There's no real plan. They bring up services as they need them. They might start with a technology and then either throw that away or whatever. They don't really give a lot of thought to it. So I've seen those companies just struggle years later with some of the decisions that they made years earlier. So let's talk about designing your system so that we can avoid that. We're going to consider how large or small your system needs to be, because is your entire business reliant upon this system? Is your company a e-commerce company or a SaaS or a PaaS or a BaaS or a CaaS or a NaaS? Now I made those last two up, but you probably get the point. You really need to figure out what your company is doing, what some of these acronyms stand for, and whether your business falls into those because it's really going to be dependent upon what your architecture looks like that might affect some of the decisions that you make going into this. Now, are you a mobile app and you just need some kind of thin backend layer to store some of your data that you're trying to save between applications and users? And will your application be for 1,000 users or 1,000,000 users? Now, a lot of you might just say, oh, I want 1,000,000 users or more than that. But a lot of you might be thinking, I just want to make an application specifically for my town or my city, and really I'm only going to look at 1,000 users, because again, this is going to affect what your architecture looks like. Now, back in the day, we used to just throw up a classic LAMP stack, and this stood for Linux, Apache, MySQL, and PHP, and you can see an example of that stack in this graphic here. So we have the application, we have PHP layer, and then that sits on Apache and MySQL, where Apache is serving up your PHP, and that creates your application, and all of that is on some kind of Linux stack. And this is really easy to set up, it's easy to understand, there's not a whole lot of pieces to it, and of course there are lots of server images that you can just say, I want a LAMP stack, and a script or just a server image can be brought up, and voila, you have a LAMP stack. But this is the old way of doing it, back when the web was young and we didn't have all these requirements. So let's talk about a modern architecture. This is an example that I put together, which will represent the application that we are going to build. And you can see on the left-hand side that we have different clients. These clients could be web browsers, mobile applications, or something in the future. We don't really care what those are at this point, nor really in the future. We're going to stay agnostic to what those are at this moment. But we know that these entities are hitting some kind of API REST endpoint, and so all those little blocks represent the different endpoints of our API, which then goes into analytics so we can figure out what people are doing. And then that's, of course, being authenticated through the authentication layer. And then going over to the right, we have a list of all of our services, such as the user account service, which handles some of our account for our users, such as account creation, maybe registration. We have the event service, which handles some of the events that come in and out of our system. Subscription service, maybe you want to have some of your users subscribe to your application. We have a notification service. This may be sending out emails or push notifications. That service there will handle that kind of thing. We also have the data service. This will handle the collection and distribution of our data. And then we have a product service. Maybe we have products in a catalog or something like that. And of course, finally, we have our health check service to make sure all these services are running and everything else in the system is running, and to notify us whether or not that's working. Then we have our data consumer, which gets data from the data adapter. The data adapter is going to handle external data sources that we might have. So for example, if you have a distributor that publishes out their inventory and you want to get a list of their inventory so that you can decide what to show on your website to either sell it or show if it's in stock or not, that's going to come from an external data source, which we'll have to handle with a data adapter. I want to introduce you to J Hipster. If you're not a server guru or you don't want to waste a lot of time setting up the perfect server, J Hipster is going to be the solution for you, and the solution that you and I are going to go through in this video series. So what is it? Well, Yeoman is scaffolding software that'll generate anything from simple applications to advanced applications running a few commands. It'll create all that boilerplate code. It'll import or include different libraries depending upon different settings that you give it. And that's going to generate a Spring Boot application, which is that green hexagon there. And the Spring Boot, if you guys are familiar, is a Java backend server framework that sets up a lot of the different things, including a whole bunch of code that is created by professionals, and it's a really great backend solution. And for the front end, we have AngularJS, and all of these together is what J Hipster is, but it gets a lot more complicated than that, so let's dive into what this looks like. Now on the client side, these are all the different technologies that we have. Some of these you might be familiar with. We have HTML5, CSS3, we have a CSS library called Bootstrap, which will handle the creation of our UI. We have AngularJS and jQuery, so if you're familiar with one of those and you want to use either one, you can choose that one. And we also have WebSockets, which will facilitate the communication between web browser and server without having to poll. So in other words, we don't have to ask the web server, hey, do you have new data? Hey, do you have new data? Hey, do you have new data? WebSockets will contact the browser and automatically update the interface without having to do that. So very, very efficient, very, very powerful. Next, in the bottom left-hand corner, we have something called Bower. This is going to handle our JavaScript dependencies. So if we want to install such things as Angular, Bower will handle the inclusion of those. We have Gulp, which will be our JavaScript task runner. This will accomplish tasks such as minification of our JavaScript, concatenation, deployment, and other things such as taking our Sass files, which is the next technology, and compiling those to CSS. So BrowserSync's a really great technology, really powerful. You can bring up Firefox and Chrome side by side, so you don't have to test multiple browsers at different times. You can just test multiple browsers at the same time. So it's very, very powerful, as I mentioned. Karma is going to be your test runner. It'll handle all your unit tests. And then we have Protractor, which will handle all of your UI tests. So for example, if we want to test to make sure that our checkout feature works, we can have Protractor run through that system as if somebody was actually sitting at a keyboard and mouse, typing these things in, clicking on different buttons, and then making sure the result is what we expect it to be. So again, lots of really cool technologies, all comes bundled within J Hipster. So that's on the front end. On the back end, we have a whole lot more technologies, but again, these are all coupled together. They come out of the box. So for the most part, you don't have to worry about them, but I am going to run through these really quickly in case you're not familiar with these, because I think these are super powerful. And if you're working on other projects, this might be helpful to you. You might have been looking for this solution and didn't know it existed. So as I mentioned, we have Spring Boot, which is going to be the majority of our Java application. We have Spring Security, which is going to handle the authentication. We also have access to the Netflix open source software, and this is going to be really powerful tools that Netflix themselves use in their solution, and of course they've open sourced that for the rest of us. We have Console, which will handle the communication between communication and discovery of our microservices. We have Gradle and Maven for our build system and dependency management, if you're familiar with Maven, if you're on the Java side, or if you're familiar with Android and Android Studio, that's what Android Studio uses is Gradle, and so this might be familiar to you. We have Hibernate, which basically takes your code and matches it up to your database or vice versa. This is very, very powerful. It's been around forever, so it's very mature. And then we have Liquibase, which is going to be your database schema migration tool. So anytime you make a change to your data schema, such as adding a column or adding a field or anything or removing it, Liquibase is actually going to create automatically a migration script to update your database schema. So if you've ever done this manually, then you've been doing it wrong, or you didn't know about Liquibase. So very powerful tool, as I keep mentioning. We have different database solutions that we can choose from. We can use MySQL, Postgres, Oracle, or MongoDB. Of course, Cassandra is on there as well. And for caching, we have Acache or Hazelcache. Hazelcache is going to be for more microservices and distributed nodes and that sort of thing. So we're actually going to end up using Hazelcache in our solution. Next, we have Elasticsearch, which is going to be our searching, which is going to give us the ability to search through our data. If you're going to have a lot of data on your server that you want to return to your user, Elasticsearch is going to be your solution for that. We have Kafka, which is going to be the communication between all of our different nodes in our microservices. Swagger we'll get into a little bit, but is going to be for API documentation and generation of code. We have Docker and Kubernetes. These are going to be your containerization of your modules, such as different microservices. So for example, you can have your database containerized. We'll go into a little bit of that later. We also have the Elk stack, which includes Elasticsearch. It includes a bunch of other technologies that we'll get into later. And then if you want to couple your front end to your back end, which I do not recommend, but this solution is available, and it's under TimeLeaf. TimeLeaf is just a templating engine for Java. And then we have Gatlin and Cucumber, which are going to be your back-end testing solutions. All right, so all these technologies, you might think that the installation is really complicated, but it's not. So what would your Gradle or your Maven script look like if you had to do this manually? Probably really messy. You'd probably have to do it over and over again. I've done things like that, and it's really frustrating. What versions are compatible with other software? So, for instance, what version of Akash is compatible with my version of MySQL? And you're going to try to match those up, and you really have to be experts in every single piece of technology in order to do this properly. Well, J Hipster has you covered because they have taken the time and done the research for you. And even if you get all these installed and you got the versions matched up, how do you connect them? What do the connection strings look like? You got to create the accounts and all these different things. And then finally, how do you generate all that boilerplate code? It's really a mess, and I don't recommend you go down this way because J Hipster will take care of all of that for you. So what does that actually look like? Now, assuming you have npm installed, you just run npm install -g to make this global, and you're going to install the J Hipster generator. And once that's installed, you go ahead and just create a directory where your application is going to live. In this case, we're going to call it Armory. And then you run the command yo J Hipster to use Yeoman to generate our J Hipster application. It'll ask you a bunch of questions, and then once you're finally done with all the questions and choosing which technologies you want to run, and again, we'll cover that in a future video, you want to model your entities with JDL Studio and then download the resulting jhipsterjdl.jh file. And once you have that file, you will generate all your entities with yo jhipster import jdl jhipster-jdl.js. And basically it's using the jhipster generator and the task import jdl using the file that we downloaded from JDL Studio. So what does JDL Studio look like? Well, it's pretty simple. On the left-hand side, you get the code to create your entities. So this is going to use an employee kind of model where an employee is part of a department, and that employee has a salary and a job, and those jobs have tasks, that sort of thing. So you get the idea. On the right-hand side, we have our UML representation of that. So we write the code. This is all browser-based. And then you can download the file and create your entities within J Hipster and create your custom application. Once you're done with that, we get a page that is our J Hipster application. So once you log in, you get these. You get this page with all the menus at the top here. You get a list of entities, your account management page. If you're logged in as the admin, which we can see that this current page is, we get administration options. And then we have localization support, which is really, really powerful. So as part of the administration tool, we get application metrics. We can see how our Java application is doing. We can see what the HTTP requests look like, how many come in as 200s or 404s or 500 errors, and see what the percentages, what the averages are, and a whole other bunch of statistics that we can look at. We also get form validation. Now, this is really powerful. Again, this uses Angular Validate to make sure that we're indeed typing in a valid email address and not just some number or something else. We also get logs, and you can see the different logging information that we have and the level of logging. And so get a lot of really useful information about how our application is running. Now, when we create the entities, and in this example, the entity is a book, and the entity has attributes such as title, description, publication date, price, and author. We get this, what I call a CRUD screen, so we are able to create, read, update, and delete these entities. You can see a list of the entities that we have in the system and the buttons that facilitate this. Now, this is 100% customizable. You would just either change the CSS or change the Angular code in the background. And so this is very easy and comes right out of the box once you create your entities. So again, out of the box, we get this fully functional application that'll handle our data, the creation of the data, account and user creation and validation, and all this stuff. So where do we deploy that to once we have this running? Well, let's talk about Amazon Web Services. These guys are very inexpensive and sometimes even free. You can send 62,000 free SMTP emails without having to pay anything. And so for a lot of us, we fall under this level. They also have a wealth of services from push notifications to long-term service, and these guys are just great. So this is what we're going to use, but feel free to use whatever you want. Now let's talk a little bit more about microservice architecture. Now I did talk about Docker, and Docker is going to be the solution that we're going to use for a lot of these microservices and deploying services out individually. And again, Docker is a containerization of our microservices. So what does this look like? Well, here's a diagram, and Docker is going to make our microservices easily manageable, easily deployable, and easily scalable. So in this diagram, as you can see, we have several instances of MongoDB, and each one of those are going to be containerized, and we can deploy as many as we need, as quickly as we need, as requests and demand go up. All right, so now you have your backend solution up and running. Let's talk about the need for an API. This is going to be the interface to your server, to your data, to your services that you're going to provide your client or your customer. So let's take a look at our diagram that we have again. So our clients on the left-hand side are going to talk to our server via the API. So one way that we're going to define our API and create our API is going to be with Swagger. We can do this in two ways. We can define our API and then generate the code, which is really nice, or we can generate the API from code that we may already have in our software. Now we're going to use J Hipster, so everything's created for us, but it still uses Swagger for the documentation and also testing out the APIs, which is really powerful. So I highly recommend you watch the next video on creating J Hipster and going through that and really looking at what Swagger can do for you. So in our diagram that we have here, we've taken care of talking about our clients, our API. Let's now talk about the next one in our diagram, analytics. I recommend either Open Analytics or you can use something like Google Analytics, but you really have to have analytics of some sort in your application because you can't change what you can't measure. So how are you going to change it for the better without just doing it and see what happens? It's a terrible solution. So analytics are just a huge necessity in our application. What about technologies for our clients, such as our mobile applications or a web application? Well, we're going to stay agnostic to who our client is when building out our backend because it doesn't really matter whether it's a mobile app, mobile web, a browser, a desktop application, or another server. So again, in our diagram, I've kept our clients very agnostic. I just call them client 1, client 2, because again, I don't care whether that's a mobile app or a web app or something else that, maybe a wearable or something of that nature. All right, so that's all I have for you in terms of architecting your backend server solution. In the next couple of videos, we'll go through installing J Hipster, some planning of our data schema and our models that we'll be using for our application, and go more into depth of what we're actually building. But I hope you found this useful, and if you have any questions, leave them in the comments below, and be sure to like and subscribe to this video if you want to see more of this. Don't forget to visit electronicarmory.com for other tutorials, and again, we have all the other videos on this channel. So, hope to see you next video, and thank you very much.